In this video, we're going to send Karel on an adventure to climb a mountain in the Swiss Alps. Or maybe actually in the Himalayas. Or maybe it's just going to be a speed bump. We're going to see mountains of all sizes. And if you haven't already guessed, we're going to be writing the Mountain Climber Karel program. So I'm going to go ahead and double-click Mountain Climber to open it up. And let's also run it to be able to see what kind of mountain we're working with. Now, you might be thinking to yourself, hey, where's the mountain? Like, that looks pretty flat to me. And that's because this is actually a special Karel program where we have to specifically load in the world that we're working with. And that's because we're about to write this so that Karel can climb any sort of mountain, no matter how tall it is. So let's go to Load World. And if you scroll down in this menu, you can actually see that there are a number of different Mountain Climber worlds. For now, let's just load in Mountain Climber 1. We can look at the others later on when we're actually testing to make sure we wrote this Karel code correctly. So I'm going to hit enter on this. And here we go. Here is the mountain that Karel is climbing. Now you might be looking at this and be like, that looks like a pretty lame mountain. Nah, it's super cool. Look, it's like 3 times Karel's height. That's pretty tall. So we're going to be writing this climb mountain program. We are going to be writing this climb mountain program using all of the principles we've talked about up until now. So are we going to be using decomposition and top-down design? Of course we are. Now, in case you've forgotten what those are, let me kind of quickly explain. Remember that decomposition is this idea of taking a really big idea and actually breaking it down into smaller, more manageable, bite-sized chunks. And the process that we're going to decompose our code with is top-down design, which means we kind of start with the big picture and break out different methods to make ourselves be able to tackle an easier and easier intellectual task. So just climbing the mountain on its own, that's a pretty tall order if we were just going to code that all inside the run method right now. How can we actually climb a mountain? Well, I would argue that the first step to climbing a mountain is that you actually have to find the mountain first. It almost sounds like an old proverb. To climb the mountain, you must first find the mountain. So let's do that. Let's find mountain. Now, once we find the mountain, we can go ahead and actually climb it. And then let's say we actually want Karel to kind of end up on the far right of the screen, like in spot 10 over here. So let's actually also then leave the mountain. And now I've got these 3 different methods that I'm going to have to write. Karel doesn't know how to climb the mountain or find it or leave it yet, so we're going to have to tell them how to. So let's start with finding the mountain. Climbing is a little bit more difficult. Let's start with an easier one. Let's do public void find mountain. Now, how do I find the mountain? Well, I know I'm at the base of the mountain when there's mountain in front of me, which means that Karel kind of needs to move until there's a wall in front of them. So we don't necessarily know how far away the mountain will be, right? If we knew the number of steps it would take to get to the mountain, we could use our for loop. We would just kind of move, let's say it was 5 away, you can move 5 times. But since we don't know, we actually need to use our while loop. We want to do something over and over again until some condition is true. And the thing that we want to repeat is just a move. And we want to move while we actually can move, while we're not blocked, right? So I think the condition we're going to use here is while our front is clear, we're going to be moving. So let's do while front is clear, let's move. Great. Now we just have 2 more methods to write. If you had to pick between choosing to figure out climbing the mountain versus leaving, which one is probably easier? It's probably leaving. So let's do public void leave mountain. Now the idea of leaving the mountain is like maybe Karel's at spot number 9 here and they've just got to make it all the way to the wall in front of him. And remember, that wall's not necessarily 1 spot away. It could be 5 spots away or 10 or 352 spots away. And we still have to make Karel get over there. If you're kind of looking at this and thinking to yourself, hey, this actually seems pretty familiar to something we just wrote, you're exactly right. If Karel's at the base of the mountain here, and all Karel's looking for is the end of the world, which we know there's going to be a wall at, I think the code is actually exactly the same as the code inside Find Mountain. You would write while front is clear, move. This might make you a little uncomfortable. I think this makes me a little uncomfortable too. And that's because it's usually pretty bad practice when you're writing pretty much any code in a computer science class to repeat code. And if we're looking at this, like, what did we do in this code? Well, we wrote two methods, one called find mountain and one called leave mountain, but they actually do exactly the same thing. How can we make this a little bit better? Well, there's a couple of different things I could try. Instead of having this code inside leave mountain, I could do this. And I hope that also makes you feel kind of uncomfortable, because now how do you leave the mountain? Well, to leave the mountain, you have to find the mountain. And that's like a very confusing proverb that actually makes no sense. So this is probably kind of a bad idea. The other thing I could do is, like, let's get rid of leave mountain completely, and let's just do this. Once I climb the mountain, I can find the mountain again. Well, that also doesn't seem right. Like, that just, like, why would I climb a mountain and then go try to find a mountain? That doesn't really make any sense either. So what should you probably do in this scenario if you kind of ever end up like this is, well, maybe I can find kind of a more generic name for this method that's a little better to use twice. So find mountain probably isn't great. I'm going to change this and just call it go to wall, which isn't as exciting. It doesn't include mountains, but I think it's pretty descriptive of what this method actually does. And it doesn't make it super confusing that I'm kind of finding the mountain and finding again, or to leave the mountain, I have to find the mountain. I think this kind of makes the most sense. Maybe not a perfect solution, but definitely it's the one that I'm the happiest with. All right, now we got to tackle this mountain climbing. So let's do public void climb mountain. And I cannot spell today. All right. How do we climb the mountain? And I don't want you thinking in turn lefts and moves and things like that. How do we climb the mountain? Top-down design. We go up the mountain. Maybe we have Karel plant a little flag on top. Maybe this is a first ascent. And then we go down the mountain. So let's do this. Let's do ascend mountain. Let's have Karel plant a flag. So I'm going to do put beeper. And then let's do descend mountain. Now, why did I just do put beeper there? Wouldn't it have been nice to actually have a method called like plant flag? And I would really argue that that's something called over decomposition, because let's say I wanted to change this, and let's say I wanted a method called plant flag. What would actually be the code inside plant flag? I think it would quite literally just be one single put beeper. And remember, we talked last time about kind of the recommended number of lines that a method should have. Every method should have 2 to 8 lines, and that is just a guideline, but I'm going to be pretty strict on the fact that you should never really write a method that's one line, because all you've done is you've written a bunch of extra code for what was just a single line of code anyways. You kind of overcomplicated things. Even if it makes this slightly more readable, I don't think there's actually any benefit here. So no plant flag method. We're just going to go ahead and do a put beeper here. All right, let's write public void ascend mountain. Cool. So how do we ascend the mountain? In some way, over and over again, I'm taking steps up the mountain. So I know that I'm repeating something over and over again. So I need to use some sort of loop here. Now let's take a look at our Karel one-page sheet. And if you don't have this out, it's probably a good idea to have it out. It's just a good reference to have. Now on our one-pager, remember, there's 2 ways we can repeat over and over again. We can use our for loop or our while loop. But keep in mind, we don't necessarily know how tall this mountain is. It could take 10 steps to get up or 25, and we have no idea, or maybe just one. So in this case, when I don't know the number of steps, I'm going to be using a while loop. And remember, I'm starting climbing the mountain from right here. If you think about it, what is the kind of condition that changes here versus at the top? I think when I'm down here, my front is actually blocked. And when I'm up here, isn't my front clear? So I want to move while my front is blocked, or I want to move until my front is clear. So I'm going to do while front is blocked. I'm going to go ahead and take one step. And now you might be screaming at your computer, oh my gosh, like take one step is not that complicated. I could have just put it in the while loop, but we're just practicing this idea of decomposition. That's all it is. And I am going to hammer it in a little harder at the beginning just so we can practice this. All right, let's write our take one step method. Public void take one step. And how do I take one step? Probably a turn left, probably a move. I think I am going to need a turn right when I'm here to face back this direction. Remember, Karel can't actually turn right, so we're going to have to write that method, and one more move. And I think this will go kind of one step up the mountain. Let's quickly write the turn right method. I'm going to do public void turn right, which of course is just going to be turn left 3 times. And now I think this will get Karel successfully up the mountain. Now, a little bit of the funny thing about this problem is that descending the mountain is weirdly slightly harder than ascending the mountain. So let's think about public void descend mountain. Remember, you always want to be kind of thinking in terms of like, what's the while loop that I'm going to be doing here? If you think about it, when I'm descending the mountain, I start off here and I'm kind of trying to get here. And if we use the same logic of how we were thinking about going up, I want to think about kind of what's true on the steps that's not true here. But there's not really anything great if I start here. So we're going to use a little trick with descending the mountain, which is I'm going to start off by just making Karel move one step forward into the space here. Now, what will that actually do for me? Well, if I move here, then when I take a step down, I'm going kind of to here, and to here. And now there is something that's kind of true up here that's not true down here, which is that when Karel's up here, her feet, which is technically her right, is clear. And when Karel's down here, now that right has been blocked. So you can see that by kind of doing this extra move, I put Karel in a position where there was actually something for me to while loop with, right? So here, let's do while right is clear. Now I'm in a little bit of a snafu here because I did just make a method called take one step, and what do I really want to put in here is also something probably called take one step. But the problem is the code for these isn't exactly the same, right? Going up a step is actually going to be different code than going down a step. So I think here I actually need to change the name of this method. It's a little confusing if I have one that's like take one step and one that's like take one different step. So let's just change this a little bit. Remember, I have to change it both when I made the method here and when I'm using it. I'm going to change this to take one step up. And then the one that I'm going to write down here, let's do take one step down. Just so I can be so kind of overly specific with this. So let's do public void take one step down. And remember, I'm going to be kind of floating in the air here. How do I take one step down? I think I first turn right. I think then I move, then I turn left, then I move. And I think we've now actually written everything Karel needs to be able to do this program completely, because we already kind of wrote our go to well method that we're now using twice, I think we are good to go here. So let's quit out of this running. Let's compile. I'm going to go ahead and run the Mountain Climber program. Let's load in our Mountain Climber 1. And I'm going to start this. Let's try it. Now, the scary thing about running this is we have kind of written a lot of code without really testing everything out, but it's a miracle. It all works. And Karel can successfully climb the mountain. But we're not quite done yet. Let's check and make sure that Karel's mountain climbing actually works on any mountain. So I'm going to load in, let's do Mountain Climber 0. And this one's actually kind of more like a speed bump, but Karel should still be able to climb it. Let's go. Go, Karel. Go, Karel. And Karel finds the wall at the end. Great success. Now we have one more to check. This is our big mountain, Karel's Himalayan peak. Oh my gosh, it's so huge. Let's go ahead and start it. There Karel goes, and Karel did successfully complete this. What was the point of this exercise? Well, we're practicing our decomposition and top-down design, as well as really practicing when to use these skills we've learned from the Karel one-pager. How do I use my control structures? How do I think about while loops versus for loops? How do I choose the right condition to kind of while loop on? Next time, we're going to be helping Karel do a little bit of light construction. And all of these ideas are decomposition, top-down design, control structures, and sensory conditions. Those are all going to keep coming into play as we keep going.